Hello everyone. Today in this video I'm going to discuss about the list of formulae from the chapter current electricity. This is the chapter from second PUC physics syllabus. So this is third chapter as you already know. So I'm just going to give the brief explanation or just terms explanation for the formulae. Topic wise I'm going to give, so you can take a note of all this and that will help you for your different examination. So starting with the syllabus, here we have the concepts like what is electric current, Ohm's law, resistance and resistivity, current density, drift of electron or drift velocity of electrons, and resistivity. Mobility is there, the effect of temperature on the resistance and resistivity of a material, electrical energy and power. Then we have the internal energy, cells in series and parallel, Kirchhoff's rules, and Wheatstone bridge. So here the first formula is the current, that is I is equal to Q by T. So we define this as the net charge or net rate of flow of charge which is moving through the given cross-sectional area. For example, if I take some cross-sectional area here, okay, and connect a battery to this like this, and this side we have positive terminal, this side we have negative terminal. So because of that the electrons flows from which direction? So they flow from negative terminal of the battery to positive terminal because we have applied electric field in this particular direction. So this net flow of charge in one particular direction will gives you the current. So now if you want the average current, we can also write the current I is equal to delta Q by delta T, and if you want instantaneous current, we write it as dq by dt dq divided by dt. So to find out current, we write Q is equal to integration of, to find out charge, we can write it as integration of I dt. So this is used in some competitive examinations to find out the charge. So this is about charge. Next we have I'm just giving you the list of formulae. So we have some theory content also here. Drift of electron. So drift velocity of electron in a material is given by Vd is equal to E tau by m. So where Vd is drift velocity, okay, and relaxation time is tau, where tau is relaxation time, and E is electric field. M is mass. Okay, so now next we have the mobility. So mobility is given by drift velocity by electric field. So we get this equation. So mobility is given by drift velocity by electric field. So since we know that drift velocity is given by E tau by m divided by E will give you E tau by m. Correct? No. So this is mobility in terms of relaxation time and mass. Next we have the relaxation time, how it is related to the resistance of the conductor and the current that is given here. Next we have the relation between current and drift velocity. Very easy formula, I is equal to V now, or we can also write it as N E A V D, or you can also write V E N A, drift velocity. So since we know that N E A, drift velocity is given by E tau by m. So in terms of relaxation time and electric field, we can write Ne square A E tau by m. Okay, so this is one important formula which relates current and drift velocity. Next, moving on to Ohm's law. So in Ohm's law, we have the current flowing through a conductor directly proportional to potential difference applied across the ends of the conductor. So from that we get V is equal to I into R. V is equal to I into R. Then we have the resistance. So in terms of voltage and current, we can write resistance like this. But other than that, we have few more formulae. So resistance is given by V by I. Also, in terms of temperature, resistance is given by R is equal to R naught 1 plus alpha into delta T. Also, then we have the resistance is given by rho L by A, and we have resistance which is reciprocal of conductance. Resistance which is reciprocal of conductance. Like this, we have different formula for um, resistance. Okay, next we have, so how does the resistance vary with the length and area of cross section? So that is given by this formula, that is R is equal to rho L by A, where rho is called the resistivity. Rho is called the resistivity. Let me just write here, resistivity. Also, it is termed as specific resistance or specific resistance. So R is equal to rho L by A. So rho is equal to RA by L. That is also there. Then we have current density. Current density J is given by I divided by A. Okay, so to remember this. So also in vector form, it is given by I is equal to J dot A. Like this also we can write. We use it in computer exams. I is equal to J dot A. And we have one more formula, that is J is equal to sigma into E. So you must know that it's a vector quantity. Current density is a vector quantity. Okay. Then we have conductivity, conductance, which is the reciprocal of resistance. Okay. Then we have conductivity, that is reciprocal of resistivity. So just like resistance, we can write conductance also in different ways. So one is resistivity in different ways. One is rho is equal to RA by L. So rho is equal to rho naught into 1 plus alpha into delta T is also there. Rho is equal to uh, reciprocal of conductance. Resistivity is reciprocal of conductivity. Resistance is reciprocal of resistance is reciprocal of conductance. Resistivity is reciprocal of conductivity. Okay, so that is one thing. Then we have just I told you J is equal to sigma into E. The sigma is the conductivity that is given by Ne square tau by m. So we have the derivation for that, but here I'm just giving you the formula for the conductivity. Okay, so then we have expression for conductivity of material in terms of relaxation time. Just here we have drawn tau is equal to Ne square tau by m. So sigma is equal to Ne square tau by m. So this is also done. Then we have electrical energy or the power. So electrical energy is the rate at which the electrical power is the rate at which electrical energy is converted into heat energy. So that is given by P is equal to V into I. Since we know that V is equal to IR, so we can get I square R also, or V square by R. So using since Ohm's law, V is equal to IR, by substituting the value of we can get that. Okay, then we have the terminal potential relation between terminal potential difference, then EMF E and IR. So that is given here also. So V is equal to E minus IR, where V is the potential difference that is given by IR, capital I into R. So you can equate these two equations. Let's consider this is equation number 1 and this is equation number 2. From equation 1 and 2, we can get, what is that? IR is equal to E minus IR. Or also we can write this is small r. Okay, so IR plus R is equal to E. So I is equal to E divided by R plus R. Then we have cells in series and cells in parallel. So cells in series are connected like this. So we have two types of cells in series combination. One is by connecting plus minus way. Let's consider the here we have negative terminal and positive terminal. If positive terminal is connected to negative terminal and positive terminal is connected to negative terminal, this is called one way of connecting in series connection. So another way is negative to negative only, positive to positive only. So negative to negative only, positive to positive only, like that. Or you can exchange also. So like this in different ways you can write this. So if you have this kind of series like plus minus, then you can directly write E equivalent is equal to E1 plus E2 plus E3 so on up to En. Okay, so if you have EMF like this, let's consider this is E1, EMF of this one is E2, this is E3, this is E4. So what happens? E equivalent is given by E1 minus E2 plus E3 minus E4 divided by what do we got? N. Oh, no, just this much we'll get. No need of divided by, because the EMF will cancel there itself. This is one way of writing that. Then depending on the direction of current also we can change this. As of now, so let's consider we have one type of combination. Okay, in the diagram you can check. So we have just a minute. Okay, we have two cells connected in series so as to send the current in the same direction. So we get E equivalent as E equivalent minus I equivalent is there, no? So that E equivalent is given by E1 plus E2, R equivalent is given by R1 plus R2, but try to do remember the same convention also. So for resistance, same convention will not be applicable, but for EMF it is applicable. Direction of current matters. And cells in parallel, in case of parallel combination, so E equivalent is given by R equivalent is equal to E1 by R1 plus E2 by R2 plus so on. Okay, then R equivalent is given by 1 by R equivalent 1 divided by R1 plus 1 divided by R2 plus so on. Then we have Kirchhoff's series is done, no? Yeah, this is parallel. Then we have Kirchhoff's laws. The net current at the junction will be 0. That is the amount of current entering the junction is equal to current of amount of current leaving the junction. That is important. And for Kirchhoff voltage law, we have this. You have to consider the transversal here. So for example, here if you consider, let me consider You can consider a transversal wherein it may be clockwise or anti-clockwise. Okay, you may have to use the sign convention. Let's consider here also the transversal is like this. What is the direction of current here? Towards left. This is I1. Here we have I2. Current I2 plus I1 join and moves in this direction. I1 plus I2. Here also same. Here the current splits again as I1 and I2. So here current will be I1 plus I2 only. So here the current will be through R5 it is I1, through R4 it is I2, R3 also it is I3, I2 only. So then you can solve this and find the answer. How to find the Kirchhoff's, how to apply Kirchhoff's voltage law? That is important. For example, here if you consider, so we have to consider EMF and the terminal potential differences. So on one side, so if you consider the transversal which is moving from positive to negative, you have to take negative transversal or negative to positive, positive EMF. And then for IR, if the current is moving in the direction of current, take positive, opposite direction negative. Based on that, we can write Kirchhoff's voltage laws and then find the answer. I can show you some examples also and explain in the numerical type question. As of now, you can just remember this. So one more hint is there. By drawing the diagram, uh, you can check the current, what is the current at the junctions, and based on that also you can solve. That is called Kirchhoff's current law. By using Kirchhoff's current law also you can find the answer. Sorry. Then we have uh, Wheatstone bridge. In Wheatstone bridge we have a bridge consisting of 4 resistors. Okay, here we have a galvanometer. Here we have a battery. Total current, here the current is I1, here the current is I2, here the current is IG, here the current is I3, here the current is I4. Let's consider this is P, Q, R and S. So after derivation we can write P by Q is equal to R by S. For this, current through galvanometer should be 0. This is called the balancing condition of Wheatstone bridge. Based on this we can solve many number of numerical as well as conceptual questions. And then we have this chart in its NCERT textbook that from where I have considered this or copied this. We have electric current whose symbol is I, dimension formula is A, so unit is ampere, and it's base unit. It's a base unit. Then we have charge that is given by I into T, I into A, because I is equal, no, this is I into T now, I into T. So then it is going to be T into A. For current is ampere and time it is T. So like that we have voltage, electric potential difference, electromagnetic force, resistance, resistivity, electrical conductivity, electric field, drift speed, relaxation time, current density and mobility. All these concepts we just now we have studied. So you can just go through this chart that will help you for your examinations. So this is all about the list of formulae. Thank you. We'll meet in the next video.